Hello guys, I'm GT Lim here. Today let's talk about coordinate system. So there's altogether 5 coordinate system that we gotta talk about today. The first one, Cartesian 2D coordinate system. Second one, Cartesian 3D coordinate system. A third one, polar coordinate system. Fourth one, which is cylinder coordinate system. And fifth one, spherical coordinate system. Okay, so let's go through the first one. Cartesian coordinate system, which is also defined as you got the y-axis and x-axis, and then whichever point P in this system can be noted by this x and y, the distance of it from the origin. Okay, so this is in a 2D form, whereas in 3D form you add a z-axis which states the height of the point. Okay, so it's same as a 2D Cartesian coordinate, just that you use z to determine the height. So whichever point in this coordinate system, it can be defined by x, y, and z. And why do we say it is a right-handed system? So if you open your right hand, you can see that your first finger, second finger, and third finger is like this. Okay, so x, y, and z is like this. Okay, it's just a way to help us easily understand how is the axis being established. Okay, so let's move on to polar coordinate system. Why do we say it's polar coordinate system? Why is it polar? So it is polar because it looks like a sphere. Okay, so you got a y-axis over here, x-axis over here. Okay, it looks like a sphere. Okay, so as you can see here, this is your point P, and your point P can be determined by r and phi. This r is a distance from the origin, or we can say that it is a displacement from the origin, and the phi is the angle of r with the x-axis. Okay, so whichever point in polar coordinate system, we use r and phi to determine its position. Okay, and this r can be 0 to infinity, and this phi can only be 0 to 2 pi. What is pi? Pi is 180 degree. Okay, so we got to find how can we get all these equations, as this is useful to turn between Cartesian coordinate system and polar coordinate system. So as you can see here, if you draw a right angle triangle here, this is your point P, okay, which have r and phi. So as we know, this is r and this is phi. So what is this? This is a vertical distance, right? So this is y if it is Cartesian coordinate system, and this is x. So if you use sine phi, what do you get? You get y over r. If you use cos phi, what do you get? You get x over r. Tangent phi, it's y over x. And if you use Pythagoras theorem, what you get? You got x squared plus y squared equals to r squared. So now let's modify this a bit. You move the r to the other side, you got this. Same goes to this. And this one, since your target is phi, you just move the tangent to the other side. Okay, and you got this. Easy, right? So now you got to revert this Cartesian coordinate system to polar system, and we got to revert polar system back to Cartesian coordinate system. So this is easy. Let's follow me. First one, let's write down the question. Next, we got to expand it. Okay, so now we just sub in the formulas from here. Okay, from here. What is x? X is r cos r square cos square phi, since it is square, right? And you got this is r square sine square minus 6 sine phi equals to 0. So you sum this up, you got this. But note that this is, what is this? This is 1, right? So we can cancel it out. So you got this. We are done. Okay, so how about the second one? X squared minus y squared equals to 1. Just sub it in. R squared cos square phi minus r squared sine square phi equals to 1, and we are done. Okay, so how about the second one? So now let's look at the second question. Okay, so you got r cos phi here. What is it? It is x. And now, since this is r, right? From here we know that x equals to r cos phi. So r is equals to x over cos phi. So we just put it in. But note that we haven't done yet because there's still phi here. So we move it to the right hand side. And then what is phi? From this fourth equation, it is tangent inverse y over x. So now we are done. Okay, so what about the second one? R equals to 4 over cos phi minus sine phi. So this you can pull it to the left hand side. So you got 2r cos phi minus r sine phi equals to 4. So what is r cos phi? R cos phi is x, r sine phi is y. And we are done. Okay, so now we got to talk about cylindrical coordinate system. So what is it so special about cylindrical coordinate system? It is a polar coordinate system plus a height. So as you can see here, this cylinder here, this circle is a polar coordinate system that we did just now, and now we introduce a height to it. Okay, so now you express a point in a cylindrical coordinate system with r, phi, and z, where z denotes the height and r denotes the point to the displacement of this point to the z coordinate, and phi is this angle between r and x. Okay, so your z can be any number from negative infinity to infinity, and your r and phi limitation is the same as polar coordinate system, since this circle is the polar coordinate system. Okay, so from these equations here, the derivation is the same as the polar coordinate system, and the z is just z, where we don't revert it to anything. Okay, so let's do some simple example here. So if you are given this Cartesian 3D coordinate system, how do you get the cylindrical coordinate equation? You just plug in formulas from here. Okay, so let's do some easy exercise here. What is x squared y squared? X squared plus y squared. What is it? X squared plus y squared is r squared. and z is z. So we are done. Okay. First question is easy. So the second question might be harder. Okay. So expand this. You got x squared minus 2x plus 1 equals to y squared, which is equals to 1. Okay. So 1 and 1 you can cancel up, and x squared plus y squared is r squared. So what is x? X is r cos phi equals to 0. And we are done. Okay. So C. What is x squared plus y squared as usual? It is r squared. So we are done. Easy, right? Let's move on to the next one, which is spherical coordinate system. This is the last coordinate system that we're going to talk about today. And why is it called spherical coordinate system? Because you see here, this circle here is the polar coordinate system that we talked about just now. And now since we are introducing another angle here, so we got another polar coordinate system here. And these two polar coordinate systems together form a sphere, which is a 3D coordinate system. So you can see here, in this 3D coordinate system, any point can be determined by r, phi, and theta. There's two angles here called phi and theta. Okay, so r is determined by the displacement between the point to the origin. Okay, just now the cylindrical coordinate system is the distance between the point to z coordinate system. Okay, the perpendicular distance. Now it's different. Now it's a displacement between this point and origin. Okay, so phi, as usual, it is the angle formed between this and this. Okay, so this r, you map it down into the x, y plane, and then this line form an angle with the x axis. So this phi is actually the same in cylindrical coordinate system. Now one thing that is different is this theta. Okay, so this theta is actually the form between the r and z axis. Okay, as you can see here, it is between r and z axis. So one thing that you need to know is just this theta. The phi is the same as the polar coordinate system. Okay, so if you see the limits for r, phi, and theta, r and phi is the same as the polar coordinate system, and this theta is between 0 to 180 degrees, as it is in between this and this point. Okay, so now let's derive all these equations from sketch. So as you can see here, if you focus on this right angle triangle and this right angle triangle, okay, I draw it out here. So you got two right angle triangle here, and note that this is the height of the point P, which is z, and this is the x system, x distance, and this is the y distance. Okay, so if you use Pythagoras theorem, you got this side is square root of x squared plus y squared, and this is equals to this. Okay, then this is theta, this is phi, this is r. Okay, so since this is the same as this, as you can see here, I call it z. Okay, so now let's apply the sine theta, cos theta, everything to it. So you got this sine theta equals to opposite this, I call it a. Okay, a over r. cos theta, but z over r. Okay, so from this you got z equals to r cos theta. Okay, so this you got a equals to r sine theta. Okay, so from here, since a is not what we want is x and y, so we're gonna do it again. So remember, this is the same as a polar coordinate system, or we can say it as a Cartesian coordinate system. We apply the cos theta and sine theta again to this. So you got what? Sine phi is opposite over adjacent. And then what is your a here? A is r sine theta. So you got this. Similarly, cos phi is x over a. So x equals to a cos phi, which is this. Okay, so from this we got this, and this. Okay, so we got the first 1, 2, 3. Next, how are we going to get this? So similarly, we use the Pythagoras theorem, but note that Pythagoras theorem we use here, the first one is this one. So x squared plus y squared equals to a squared. Okay, so if you apply Pythagoras theorem here, you got a squared plus z squared equals to r squared. So if you write it out, a squared plus z squared equals to r squared. But in the first, we got this, a squared. So can you sub second equation into first equation? Okay, so we rub this off. Okay, if you sub second into 1, you got this, and we are done. Okay, so what about this one? Actually, it's just applying tangent phi to this triangle, and for this one, you just apply cos theta to this right angle triangle. So I'm pretty sure you all can get it by yourself. And let's move on to exercise 3, where we want to find a spherical coordinate equation if you're given all these equations. Okay, so as you can see here, since you got x squared plus y squared plus z squared equal to r squared, it's pretty easy that the first one you can say it is r squared equals to 1, and we are done. The second one is slightly different, so we gotta do it later. And the third one, since this is r squared, so we just write down and we are done. Okay. Oh wait, this z we can still further simplify it. As you can see, there's this equation, so you can put it here. Okay, and we are done. Or you want to simplify it to this, it's up to you, but it's the same. Okay, so now let's move on to the second question. You got the square root, can you move it to the other side? I'm pretty sure you can do it. Okay, so now you got this, and what's next? You just sub this 2 equation and this equation into here. Okay, so z squared, so you got r squared cos square theta equals to r squared sine square theta cos square phi plus r squared sine square theta sine square phi. So if you factorize this out, you got this. And note that cos square phi plus sine square phi, it's 1. Okay? So we can just take it out. And here, this r square and r square can cancel out. So what equation you got? You got cos square theta equals to sine square theta. So what is this? What is cos square theta equals to sine square theta? It's similar to tangent square theta, right? So what you're gonna do is you move cos square theta to this side so that you got 1 equals to sine square theta over cos square theta. So this is tangent square theta. So tangent square theta equals to 1, and we are done. That's all for today. If y'all would like to see more math and engineering mathematics video in the future, see you guys next time.